everyone, so welcome to my channel. In this video, we will continue our introduction about linear regression. So in our previous videos, we already introduced some terminology about the linear regression, about the empirical model, and how we can do the linear regression. So in this video, we will talk about some property about the least square estimation. So in our last video, we already get the formula of our beta 0 and beta 1 in our empirical model. So this is the numerator is s sub xx, and denominator is numerator is s sub xy, and denominator is s sub xx. So also, in fact, here this is a sum of the product of xi yi minus the n times the sample mean of our x and the sample mean of our y. And denominator is looks very similar. Actually, the form is very similar to numerator, but just rewrite everything with x. So then for the parameter of this beta 1 hat, what we want to talk about is we want to talk about this estimator. Is this a biased estimator or unbiased estimator? And also we want to talk about the variance of our estimators. So about the the bias or unbiased, what we can do is we know unbiased estimator is if the mean of our estimator is equal our parameter, then this is our unbiased estimator. So the lucky thing here is if we compute the mean of this the beta 1 hat, we will have, so this is equal our beta 1. So here, of course, I skip the computing about this part. So if anyone interested in this one, you can leave a comment in the video, and maybe I will upload a video about how to compute this. So that's it, because we have the mean of our beta 1 hat is equal beta 1. So this means our beta 1 hat is an unbiased estimator of our beta 1. So if you remember in the last video, I said when we construct our linear line, so there is a different way to create it, right? So here when we describe the best fit line, we use the least square. So of course there are some other way to construct this best fit line, or to measure the distance between the point and the line. So here the lucky thing is if we use the least square estimator, then this is an unbiased estimator of our parameter beta 1. But if you use other method to construct this best fit line, then you need to check the mean again to conclude it's an unbiased or biased one. So then about the variance of this one, of course here we also compute the variance of beta 1 height. So in fact this one, this will equal the numerator is just our sigma square, and the denominator is our s sub xx. So here the sigma square is the variance of our residue. So this is the mean and variance for our beta 1 hat. And then the next thing is how about our beta 0? So previously we already give the formula of our least square estimator of our beta 0. So this is the sample mean of our y minus the estimator of our beta 1 times the sample mean of x. So here about the mean of our beta 0, of course I will skip the calculation again. So the answer of this one is the mean of our beta 0 hat is still our beta 0. So this means our beta 0 hat, the least square estimator beta 0 of beta 0 is still an unbiased estimator of our beta 0. So then when we want to compute the variance of our beta 0, so we will have this is a variance of our equation. So based on the linear property of our variance, we know this is a two term, the sum of two terms, right? So the first one will be sigma square over n, and the second one is sigma square times the square of the sample mean of x divided by the s sub xx. So of course we can rewrite this if we group by the sigma square. So this is a variance of our beta 0 hat. And when we compute in our last video, we also give one estimator about our sigma here. So here the estimator of our sigma is equal the sigma square hat is equal the SSE divided by n minus 1. So if we plug in this equation, so we will have use this estimator to substitute our sigma square. So we will have the variance of our beta 0 and beta 1 will become, it's just as these two equations. So this is about the variance, right? So the next thing is, if we have variance, of course we can talk about the standard error of our beta 0 and beta 1. So the standard error is similar like the standard deviation and the variance, right? So it's just a square root of our variance. So that's why we have the standard error of our beta 0 hat and beta 1 hat as these two equations. So this is a property about the least square estimator of our beta 0 and beta 1. And also based on our estimator of our sigma, so we can also rewrite this equation with our estimator of sigma as sigma hat. So in our next video, we will continue on the linear regression. We will work on the hypothesis of our linear regression. So now we combine the statistical inference and also the linear regression. So please subscribe my channel and see you in my next video.